All right, we have one last question or one last slide that we're going to take a look at in this section 3.4, and it's this one, example number 4. We have a student, and the student observes that 39 plus 41 is 40 plus 40, and asks if 39 times 41 equals 40 times 40. And the first question we're asked is, how do you reply? A very slightly different question next, but how do you reply? Does it work? No, it doesn't. How could you justify that, Nicole? Any thoughts?
I guess it makes the number a lot bigger.
Okay, could we just multiply those sides to see if it worked? That'd be one way to just check really quickly on this specific example to see if it worked. So let's actually do this for this specific example. You guys probably can do the right-hand side in your head. What's 40 times 40? 1,600 actually on that one, yeah. 1,600. And then what about 39 times 41?
1,500.
What was it?
1,595.
Okay, so they're not the same, right? That would be the left-hand side and the right-hand side of those respectively. But they're awfully close, which is very interesting, right? They're really close. They're only off by 1. So I want to show you a little bit about what's going on here. So this is the one I want to talk about, or the next one? Let me see, just a second. Yeah. Okay, so I want to take a look at when this would actually, or why this is actually not working. Let me say it that way. So let's look at these two numbers. How would you describe these two numbers that we're comparing in both the addition example and in the multiplication example? They're two apart, right? And not only that, but they're two apart around a number that's a nice number in between, aren't they? I mean, we're one higher and one lower than a multiple of 10, which is really friendly. So in essence, though, what we're doing is we're taking a number and we're taking a number that's one more than that, two more than, that number. Two numbers that are two apart. Okay? So what happens when we multiply these together? What do we get? Using distributive. X squared plus 2x. That's what that would be, right? Now, let's actually take a look at what happens on the right-hand side. If we call the first number, that is the 39x, how could we relate the number 40 to the x that we called? You see, 41 we decided is x plus 2, so what's 40? Not minus 1, plus 1. Because we called this x, and we called this one x plus 2, right? So if we're using that notation, then we could say that the 40 right here would be x plus 1. Right? So what happens if we did x plus 1 times x plus 1? How does that actually compare to the x times x plus 2? Because that's what we're doing in general. So what happens if I distribute and I multiply all of this out? What do you get? Plus what? 1. How exactly do they differ? By the 1, which is exactly what we found out when we did the specific example, right? So that specific example actually works in general. If I were to always decrease one and increase the other one to find the number in between, I'd always be off by the number 1. That's actually pretty friendly. So this never works in general, so this never works. But we'll call it just the right-hand side. So the right side, which we would have had as 40 times 40, is always 1 greater. And this actually over here shows it, doesn't it? I did it in general, just called something x, and I related every other piece to that the original x. So when it was x plus 2, the other one was x plus 1, and I multiplied, and I said, okay, let's compare. So this will always have 1 greater on the right-hand side than it was on the left-hand side. So it actually never works. All right, here's another one, slightly different. This one says, another student observes that if you take the 39 times 41, you get 40 times 40 minus 1. Do you? Yeah, that's what we just showed, right? He also found that if you did 49 times 51, you get 50 times 50 minus 1. Okay. He wants to know if this pattern continues. How do you respond? What do you think? Yeah, that's what this up here shows, right? It shows that this pattern will work. So yes, it works. As long as what's happening. How could you describe what's happening to those numbers on the left compared to the numbers on the right? Well, what's going on here? What are the conditions around which this works? Okay, so it looks like it matters that we actually have multiple of 10 on the right hand side. At least the two examples we've tried, they have that, right? So this, in other words, we're getting 50 here and 40 here. It seems like there's a multiple of 10 thing going on. What else do you notice?
One up, one down.
Yes, so there's always one higher and one lower than that multiple of 10. That's what it's looking like, right? Okay. But the question is, does that really matter, or is it just sort of a convenience thing that made it nice? Well, the fact that it was one up and one down really mattered. How do you know? That is, the two numbers on the left must be, or let's say this way, must differ by 2. Okay, so I'm not going to be able to do this, at least I haven't shown that I for sure can do this, if the numbers say differ by 5, right? That this is not a process by which I can use the number 52 and 47. But I didn't show anything about 52 and 47 because those are 5 apart. Are you guys following with that? The only thing that I've looked at is that the numbers have to be 2 apart on the left. Make sense? And then I showed that this is what happens over here with sort of some general algebra, right? By letting x equal some number and then one number be 2 higher. But did it actually end up coming into play that the numbers had to be multiples of 10?
No.
It didn't actually, which means this should work for any numbers, right? So if I chose that I wanted to do 42 and 44, it should work. I should be able to do 43 squared, 43 times 43, then minus 1. Because the algebra that I did didn't really have anything to do with whether the number was a multiple of 10. It's just really convenient when it's a multiple of 10, right? Because you can multiply multiple of 10 by itself really nicely. It's got lots of zeros in it. So the only condition really that mattered was that the two numbers on the left have to differ by 2 for this to work. So the two numbers on the left must differ by 2, and this is, we'll say it this way, as shown above, and I'm going to put in red here because I used red, but you can draw an arrow to yours. That this always works, and the only thing that mattered was that the numbers were 2 apart. It's the only thing. Nothing else actually ended up coming into play. Alright, so that's the last one in